Hey everyone, this is Varun. I'm a partner engineering manager at Meta. My team at Meta is responsible for increasing the adoption of Llama by making it easy for the developers to use it within their applications. So today I'm going to be talking about what we released with Llama 3. And we'll do a quick lab exercise learning about different prompting techniques. So I would like to keep it interactive. So if you have any questions or something, please let me know. I would love to answer them. So Llama 3. So it is the state-of-the-art model that we released. And it is one of the most powerful, openly available model of its size. We released two versions of the model, 8B and 70B model. And the way it is really better than Llama 2 and where it gets really good is with reasoning, coding capabilities, as well as following your instructions that is given in the form of like prompt or any other instructions in RAG, etc. To do a brief recap as to how we got here, we first released Llama 2 and Code Llama back in August 2023, and the adoption of these models have been insane. So we have had well over 170 million plus downloads and over 50,000 derivatives on Hugging Face. I want to have a quick question here. How many of you are aware of Purple Llama? Okay, so we have to fix that part. So we have recently renamed it to be called Trust and Safety. So Purple Llama is essentially a set of models and tools that is developed and shipped by Meta that will help you develop your applications in a safe and a responsible manner. So I'm going to talk briefly about it. It's going to be a complete talk on its own, so I'm not going to be double-clicking here, but I'm happy to answer any questions after the talk. So we launched Purple Llama back in December, Code Llama in January of 2024, and 2 weeks ago, we launched the Llama 3, 8B, and 70B model. The Llama Guard 2, so this is essentially provides input and output guardrails, which we announced along with Llama 3. CyberSec evals. So this is a industry first, I would say, in terms of helping you evaluate the LLM's susceptibility to prompt injection, cyber attacks, and code interpreter abuse, etc. So this has not been done before. So if you're fine-tuning your model and you're using it for productivity use cases, and you want to validate how your LLM is doing, this is like one of the good benchmarks to look into. Then we also have Code Shield. This is a Python library that will help you evaluate if the code that is generated by your LLM is safe or unsafe. Because as you rely more and more with the LLMs to generate the code for you, there is a very high probability that these LLMs can introduce cyber attacks or issues that you're unaware of, and you just accept the diff and you move on. So these are like some of the libraries that we also introduce and build as a part of the broader trust and safety umbrella. A little bit more about Llama 3. So Llama 3 was pre-trained with 15 trillion tokens. This is 7 times more than Llama 2 dataset, and it has 4 times more code compared to Llama 2. We also introduced a new tokenizer, which is of length 128K. What this means is it can encode your input prompts much efficiently and thus overall improving the performance of the model. With the upcoming release of Llama later this year, we are focusing on building a multi-model, multilingual. We trained the Llama 3 with 5% of data set on non-English languages, covering up to like 30 plus languages. So though we do not guarantee the same performance as English, but this is in preparation of the launch that we are expected to do later this year. I'm not going to bore you here with the benchmarks, but it is published on the paper. You can look into it. But this is like some of the standard benchmarks, as Jackson was asking previously, in terms of how do you compare the LM models. These are like some of the LM harness is one of the standards that typically most of the companies evaluate against. So a preview about what to expect next, right? So we are releasing a 400 billion model. This is going to be big, huge. And this is like a checkpoint from April 15th. This is not so long ago, 2 weeks ago. And the numbers already look fantastic. And we are not done training yet. The training is still in progress. So multilingual, as I mentioned previously, multi-model, multilingual, and larger context windows is what we are looking to do as a part of Llama 3 version 3.1, 3.2, whatever that's going to be. With that, we're going to quickly switch over here to a notebook where we're going to be doing a little bit about prompt engineering here. There is a lot in this notebook. I'm going to be sharing the link to this notebook later on. You can run it yourself. It is running on Google Colab. We are going to cover only a couple of topics in the interest of time. But I want to capture for you to take away a couple of things from this. One, what is the main difference between Llama 3 and Llama 2 and how it is better? And some of the prompt engineering techniques that is very effective when it comes to working and building your AI applications. So I have pre-run this notebook. Otherwise, you will see these dependencies and everything installed. So I'm going to scroll through and talk over some of the key sections. So this demo uses Replicate, which is a cloud hosting provider that has all the Llama models hosted. So we are just using this as API as a service. So here on the first cell, we just run this method to kind of like copy over the API token from Replicate. So once it is set up, we will be running the inferencing on Replicate. I have some helper functions here that is defined that will allow you to run inferencing on a Llama 2 model, Llama 3 8B, and Llama 3 70B models. There's nothing fancy. It's just basically a REST call over here. So it should be straightforward. Now let's run some prompts which says like, hey, what's the typical color of Llama? And here you can see Llama 2 comes back and says that, oh, I have to really go find the answer here, right? It's Llama can come in variety of colors, including white, gray, brown, black, and among others. Now let's see how Llama 3 does. With Llama 3, it is much better. It gets to the bottom of it saying, hey, Llama is usually white, but however, they come in various colors. So Llama 3 is not as chatty as Llama 2. So you don't have to start parsing and negotiating with the responses with Llama 3, so it gets much better. Raise of hands. How many of you know about the hyperparameter, what the temperature does? Okay, so let me quickly go over that. So the temperature is a hyperparameter that lets you set how deterministic you want your output to be. So let's say you set the hyperparameter to be 0, then you get consistent response and the same response from your LLM. But let's say you set it to 1.0, your model is going to be very creative with its responses. So especially when it comes to writing poems, storytelling, etc., that's when you want it to be more creative versus you're asking it to answer something straightforward. You want to set it to be 0, right? So here, quick run, temperature set to 0. Again, this is the color of llama. I was like, what are we prompting? So it comes back to say, hey, llama is white, right? And you run it with llama 3 8B, it is pretty consistent. Here you can see that it is the same response that you're getting back from the model. Now, let's increase, if you increase the temperature to 1.0, right? So here you can see the response has changed. The typical color of llama is white. And so as you keep on trying it, you get different kinds of responses, right? So with the temperature 0, you get the exact same results, but as soon as you set it to 1.0, you start getting different answers. Next, over here, LLMs are stateless in nature. So what that means is when you ask a question, it responds and it forgets what you asked, right? It is your responsibility. It is just like your REST APIs for the most part. You make a request, it remains. So if you want your models to be, for your LLM to remember what you had previously asked, it is your responsibility to include that as a part of the context. So I'm going to be talking about how we are going to do that. So here, there's a prompt here which is like, hey, what is the average lifespan of llama? And answer it in few words. It says around 15 to 20 years. So this is what llama 2 says. Now, when you run the same thing with llama 3, it comes back and says 15 to 20 years. Now, let's say we change this prompt, right? And now we say what animal family are they, right? Answer the question in few words. Now, when you run this against llama 2, sure, it responds and it starts blabbering here. It really does not know what it is talking about, right? Now, let's try it with llama 3 8B. Now, when you run this, it comes back and says mammal. So it is respecting answer in few words, like llama 3 is doing better. But at the same time, it is still hallucinating, right? Now, let's try it with llama 3 70B here. And now this gets smarter. This is what I was saying. It's better with reasoning, etc. So please provide the animal's name and I'll respond to you with the family in few words. So as the models get bigger and better, they get really good with having a proper conversation with humans, right? Now, I promised you we're going to talk about how do you provide this context. So this is what we call as multi-turn chat, right? So here we will continue to have a history of the conversation of what was happening. Now here you see that as a part of my prompt, I will say, what is the average lifespan of llama? And my agent got back to say that it is 15 to 20 years. And now I ask the question to say, what animal family are they? So I'm passing this entire thing. And now let's see what llama 2 does. So now it comes back and says that, hey, it is part of the Camelidae family, which is the right response. Now, if you do the same thing with llama 3 8B, now llama 3 8B is also getting better. Now it has enough context in the prompt. Now it is able to come back with proper response to say, hey, it is part of camels, alpacas, and gunacos. Now, as the reason why I'm talking a little bit more about here, it is also to remember that your prompt makes a lot of difference. So that's the key thing, right? So here, now let's get a little bit more specific. And now I'm going to be saying, hey, this is the context, but I want you to answer in one word. I don't want you to be too chatty, right? And when I ask llama 2, it still says, hey, llamas are part of Camelidae family. Great. Now the same thing with llama 3 8B. Now it is no longer having like longer sentences, but it is sticking to the point and saying it is camelid, right? So Llama 3, the takeaway here is it follows your instructions much better than Llama 2. And it all depends upon how you are prompting these models. Now, the next section here, we're going to be talking about prompt engineering. I don't know, like if you everyone follows your Elon Musk. He recently posted, I think like 2-3 days ago, where he said, parenting is like prompt engineering for 18 years. So that's how, and that's what it takes, giving instructions so that people follow, right? So prompt engineering is essentially that. It is a science of giving effective prompts so that you get the desired responses. And this will help reduce the hallucinations with the models. So that's why it is very important to think about how you prompt your models. So in this section, I'm going to be covering a couple of techniques. The first one is going to be in-context learning. In the in-context learning, there are like a couple of kinds, but here you are giving the task, specifying the task as a part of your prompt, and then you're asking the LLM to respond based on the given context, right? So with zero-shot learning, you are not providing any examples to the model. So based on its pre-trained data, it will understand and it will give you the response, right? But with few-shot learning, you prompt your LLMs with some examples and your expected responses. By that, your LLM learns what you're expecting and then tries to answer based on what you want. So that is few-shot or n-shot learning. So we'll look at like a couple of examples here, right? So this is like sentiment analysis. So I give a statement in here to say, hey, I saw gecko. Give one-word response. So when you ask Llama 2, it says, it's interesting. But I'm looking for more about, hey, tell me whether it is positive, negative, or neutral, right? That's the sentiment that I would like to understand. And when you ask Llama 3 the same thing, it says neutral. So Llama 3 is doing much better than Llama 2, even without any extra effort here, right? Now, to make Llama 2 do the same thing for me, I do it by giving like a few examples about what I am expecting. So over here, I say, hey, classify, I love llamas, and I think this is positive. I don't like snakes. Now this is negative. I saw gecko. Now you tell me what is this sentiment going to be. Now when you ask Llama 2, now it comes back and says, hey, this is neutral, which is what we were trying to look for, right? And now when you ask the same thing with the same prompt with Llama 3.8b, you get it back as neutral. Now, Vicuna, this is like also one of the Llama family. Now, when you ask, what's Vicuna? Like it does not have any other context, right? So when you ask Llama 3.8b, it says, hey, this is like fiber. When you ask Llama 70b, it does even better. It says, hey, this is the llama. This is like some of the examples. Like I still have like a couple of other things that I want to cover here. So I'm going to quickly skip over this section. At the end of the day, what biggest takeaway from this part is like the Llama 70b tries to explain the answers better because these are also like bigger models. Okay, so chain of thought. We heard this question coming up, right? This is like a very important technique within prompt engineering. It is just like us trying to solve a word problem, right? When you're given a problem, you try to break it down into different steps. That's the same thing that's also happening with the LLMs. Now, I give it a problem here to say, hey, you started with 5 tennis balls, and then it buys 2 more cans, with each can having 3 tennis balls. So how many tennis balls does the llama have? And here we are forcing the llama model to say, you answer to me in one word. You don't have to do the math. The answer is 11. But over here, llama 8B says that it is 17, right? So it tried to do something and came back and said it is 17. But when you ask the same prompt with 70B model, you will get back the right answer. So this is what I said, better with reasoning, better with instruction, and processes your prompts better, right? Now, Llama 3 models applies chain of thought automatically behind the scenes. Like that's the key thing, right? So it does better compared to like Llama 2. Now, when you prompt here the chain of thought, like how many tennis balls does Llama have? And you ask Llama 3 8B, which previously gave you back, remember it gave back as 17. Now here, when it's like breaking down, you're not asking the llama to answer in one word. Remember, the previous prompt said one word. Now we are not saying one word. It's like, do your work, whatever you're supposed to be doing. Now it breaks down the problem here in a lot more understandable way for the model and comes back with the right response of love it. The next example is like knowledge prompting. This is what I want to talk about. So within like knowledge prompting, right, the way it works is you provide the context, you define the task, and you specify the desired output within your prompts. So when you do this, then your LLMs performs better. Now, let's take like a couple of examples here. Over here, we are talking about golf. And here I'm saying like, hey, the part of golf is trying to get a higher point total than others. Is this right or is this wrong? And Llama 3 8B comes back and says, yes, it is right. But actually the answer is wrong, right? So you want to be completing your rounds with as many lesser compared to the other players. So then I define the objective within my prompt to say that, hey, the objective of the golf is to play a set of holes in the least number of strokes. So now the model has this additional context and additional objective. And now we are asking the model to explain its answer. Now the 8P model comes back and says that, hey, the answer is no, which is the expected answer, right? And now the same thing when you try to do it like Llama 70B model, it is very similar. It comes back as no. It does not meet the broader objective or the task. Again, bigger model, better reasoning. The next one is like, we speak about like RAG. I think David spoke a lot more about RAG than what I can cover in the amount of time that we have. But he did speak about like one topic, which is like relevant that I want to like demonstrate as to how to do what he was talking about, as well as one of the techniques. So this is like decomposition question. Like how do you break down a complex problem that you're trying to solve, like using RAG and Llama 3, right? So here, I'm going to be giving like a simple instruction to the model to say that, hey, you're a domain expert. You can break it down into complex. You can break down the complex questions into simpler subparts, right? So, and then try to find the answers within the document that was given as a part of the RAG implementation. So the question here is like, what's the revenue difference between Q1 of 2022 and Q2 of 2022? This is all I'm asking. But then I'm expecting my model to break down into smaller sub-questions. So when you ask Llama 2, it comes back and says like, hey, help me answer these questions, which is like, what is the time period being compared? What is the revenue data source? How is the revenue data collected? But I have already given all that information as a part of my prompt, right? So Llama 2 is not able to do that great job when it comes to this. But when the same thing, you prompt Llama 3 8B, it comes back with the right set of questions we should be looking for an answer for within the document that you have given the LLM. Here it says, hey, what is the revenue for Q1 2022? What is the revenue for Q2? Now, once I get these answers, then I will be able to answer the question that you're asking for. So takeaway, Llama 3 breaks down the problems and breaks down complex. So that's how it kind of like breaks down the complex questions into smaller subparts. And with that, I will stop my talk here and open it up. Oh, well, one part that I do want to cover, I'm sorry. I have linked there are some of great resources that's available that is built and maintained by Meta employees. So this is the Llama Getting Started Guide. It has a lot of working examples about implementing various APIs and all of that. This is Llama Recipes. This is essentially cookbooks and examples of how to do certain real-world applications, right? So if you go in here, it has libraries that will help you with fine-tuning, quantization, how to integrate with other API service providers, how to build chatbots. It has working examples and notebooks, which you can just take it and be able to execute and run with it. So you don't have to spend too much cycles trying to build proof of concepts. How to use Llama. That's the thing. We try to make it as easy as possible for everyone. There's also a deeplearning.ai course specifically on prompt engineering that is run by Amit Sangani, who is also my manager, where you can go a lot more deeper into prompt engineering. With that, thank you. The way I would say here is the way wherever you're hosting your models or wherever you're using this API, you're typically billed against the number of tokens your LLM is generating, right? So if there are, with Llama 2, you had to do the chain of thought to kind of solve complex problems. But with Llama 3, you don't have to do that. As long as it is giving you accurate answers as what you are expecting, then I would say that the number of tokens used is far lesser compared to Llama 2. But if it is not serving the purpose, but it is responding in one way, but it's not answering, then it does not serve the purpose that you're trying to do. So it does reduce as long as it is solving your problem. That's the way I would put it. I mean, that's a hard question that is a function of multiple variables because it depends upon your data set. It depends upon what you're benchmarking against. It also depends upon how you are evaluating the models. So it's a hard one. I don't think there is a definitive answer that I can give for that one, unfortunately. In terms of did we increase the vocabulary size? Yes, we did. What that means is the number of tokens, the optimization here to speak for numbers specifically, the new tokenizer is 15% more efficient than Llama 2. So what that means is it uses far lesser tokens to do the same job compared to Llama 2, which would essentially help improve the overall efficiency of your model. I think this problem is going to persist regardless of what model you end up using as soon as you start maxing out the context window. So it is not specific to Llama, I would say. It is like a generic application. How you build your application is. So there are various techniques to answer to your question. One, as you go through your chat history, some of them can become repetitive or is no longer relevant. So what are the techniques that you kind of like apply that would allow you to like summarize the previous set of conversations that should be sufficient enough for your chatbot to respond effectively to the next set of questions coming in. So there will be like a constant pipeline of how you're cleaning up your previous prompts and summarizing it so that your model can effectively respond to the new questions that is coming up in the pipeline. And just a small correction, which is like the context window for the Llama 3 is 8K. It is not 128K. The tokenizer length is 128K, which is like how efficiently the models can compress the data. So that's the tokenizer. But the window size of Llama 3 is 8K. And this is something that we are looking to make it bigger and better as we release the future versions of Llama.